Okay, before I stop the video, I wanted to just do one more inequality and see how we do. So, how about if we try to solve something a little bit simpler? How about if we just try to solve the absolute value of 2 minus 3x is greater than or equal to 5? Well, if the absolute value of 2 minus 3x is greater than or equal to 5, then what does that mean about just 2 minus 3x? 2 minus 3x must be either greater than or equal to 5 by itself, or 2 minus 3x must be less than or equal to minus 5, right? Does that make sense? And so sometimes we can combine both of these into our expression. Let's see. Well, let's just go ahead and see what we get here. In this case, I'm going to take the 3x over, bring the 5 over, and so it looks like 2 minus 5 is minus 3, greater than or equal to 3x. So x must be less than or equal to 1 there, right? Oops. Let me not jam all that up there. X is less than or equal to negative 1. And on this side, if I bring the 3x over, the 5 over, 5 plus 2 is 7. So that's going to be 7 is less than or equal to 3x. And so in this case, x is going to be greater than or equal to 7/3. Okay, and so in the number line then, x is going to be less than minus 1 or equal to, or it's going to be greater than or equal to 7/3. Oops, 7/3. Okay, now we were talking about distance. And so how is this a distance function? Well, it's not quite in the right form yet. What happens if I were to factor out minus 3 from this expression? Then I would have minus 3 times x minus 2 is greater than or equal to 5. Then if I pull out the minus 3, it becomes a positive 3. So 3 times the absolute value of x minus 2 is greater than or equal to 5. Oops, 2/3. And so now we get that the distance between 2/3 and x is less than or equal to, oops, sorry about that, 5/3. And so my 2/3 is here, and notice that if I go positive 5/3, then I'm at 7/3. If I go negative 5/3, I'm at negative 1. So my 2/3 is sitting in here somewhere, right? And so the distance here is 5/3, 5/3 distance here, 5/3 distance here. Okay, enough of that. I just wanted to talk briefly about distance in general, distance in the plane. And the distance in the plane depends on the old right triangle. So A, B, C. Do you remember the Pythagorean Theorem? Of course we do. C squared equals A squared plus B squared. The sum of the hypotenuse, or the sum of the square of the legs, the sum of the squares of the two sides is equal to the sum of the hypotenuse squared. Remember that because, do you guys remember the Wizard of Oz? When the scarecrow gets a brain? Oh, let's see what the scarecrow does when he gets a brain.
Anybody can have a brain. That's a very mediocre commodity. Every pusillanimous creature that crawls on the earth or slinks through slimy seas has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
Ph.D.?
That's Doctor of Thinkology.
sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy, rapture! I've got a brain!
Oh no, he got it wrong. Did you catch it? Go back through and see if you can catch it if you didn't catch it. Yeah, it's kind of classic. There's all kinds of things wrong with this video, with this clip. For one thing, you don't need a brain. All you need is a diploma. Okay, that's all kinds of... Okay. Let's go back to our math now. Okay, so we got our Pythagorean theorem here. And so, using the Pythagorean theorem, we can find the distance between 2 points in the plane. So if I have, let's call it xy and AB, then the distance between the 2 points, you can see, we think of as the hypotenuse of some triangle. And so that's our, let's call that our distance d. And so our distance d is going to be the square root of a squared plus b squared. Well, it's the square root of that, right? But that, in this case, this is our distance in the y, so that's b minus a. And over here we have, whoops, not b minus a, but b minus y. It's the difference of y's, right? And this is going to be the difference of x's. So it's going to be, maybe I should write this different. Sorry about that. Let's call this x2, y2, just to be sure that it makes sense to you later. So we're not doing the scarecrow thing. Okay. So let's call this one x1, y1. Okay, then it's going to be the difference of y's squared plus the difference of x's squared. Oops. Good. And so that is the distance formula. And so we can do fun things like, what is a circle? If I fix a point, AB, find the set of all points xy such that the distance to AB is r. Well, using our formula, that means that r is equal to the square root of the change in y minus b squared plus x minus a squared. Now if we manipulate this expression a little bit, we get that x minus a squared plus y minus b squared is equal to r squared. And this is the equation of a circle of radius r. Right? And center AB. And so that is indeed what a circle is. Very good. Okay, I think we're going to stop here. We're going to continue our review next time. We're going to have go ahead and look at the class website. And that's the one that lists the videos for the homework. And the first homework will be due on Wednesday, so we have Tuesday to kind of think about it. I do want you to do something for me by Tuesday, and that is I would like for you to upload any PDF file to your Canvas website. So this is just for practice, although I'll count it as a single point, just to give you a little more motivation. That's what I'm looking for. Good. So again, for Tuesday, go ahead and upload any PDF file you want to your Canvas account, and then on Wednesday, the starred problems from the homework will be due, and that means we'll be uploading those to the Canvas website as well. But that's not until Wednesday. So you can have pretty much all day on Wednesday to work through any last minute things from tonight's homework. Very good. I will see you on Wednesday, if not before.